Good, how you been? Send it to me.
Is that this week?
Hi everybody, cuddle up and read here. If you didn't read what got sent out in the email today, I'm sorry, probably sent out last night. But this is going to be our first topic what we're going to discuss. Cuddle up and read. If you didn't read the email that was sent out this afternoon, that's going to be our first topic. Back to there. Specifically, we're concerned with the kind of what they're doing with the stock market. Specifically, we're concerned more with what they're doing with their stock market here. So, everybody's read it, but all right, everybody through? Read this? Okay. So, what do you think they're about them paying back? I might have missed something. Okay. Buying back $60 billion in their own shares after they've dropped 40%. And as near as we can tell, they don't seem to be planning on introducing a product anytime soon. So, I mean, do you guys think this is a good thing? Is this a good business move, or is this or is this kind of foolish, given their history so far?
Depends on what's happening with the research and development, I guess.
Okay.
They know more about that than we do.
Yeah, they may be kind of holding back and just trying to keep everyone at bay until they get ready to drop something new, but I don't know.
Could they could they make a large profit out of their stock following this part? Could they do it even better than they're doing it?
Yeah, they might sell it, now that they can get those cheap, and then if they come up with the new products and the share price goes up, then they'll sell it.
Okay. Initially, as Nikki and I were talking the other night about this, when I first read this article, this is from BBC, by the way, this seemed really, really foolish to me because it doesn't, as far as we know, they're not planning on introducing another product till the summer, and their stock is going to go probably down for a ways. I mean, it went up about 5% after they did this, but there's much better things they could do with that $60 billion. And if you've got $137 billion cash on hand, as Nikki and I were talking, the smart thing to us to do is to, and this is a risk analysis society, so this is kind of why we thought this was a good topic here. But how Nikki and I saw it, the better thing to do would be to just let the stock fall. You need to let it go down, and instead, just invest $30 to $40 billion in R&D and come up with just a phenomenal product. And let your stock fall. Don't worry about it. And then when it gets down to $200 a share, then you go back and buy 80% of it, or pretty much you buy up as much as you can left with cash on hand. Then you come and reintroduce a product. Now, some of your current stock people are going to hate you, but they're just there kind of riding on what you're doing anyway. And you're not going to get really good investment until you can actually show that you can control your stock and that you can develop your amazing products again. So at this point in time, it seems like a bad idea because they're going to lose part of this money until they introduce a new product. So it seems to us, Nikki and I, it seemed like an absolutely horrible plan to be investing now when there's no product launches looking until the summer. So they could handle this much better. And the reason that we saw, and they're paying dividends now and increasing what they're paying on dividends, but that's coming from a lot of pressure from investors and everything because I think they only maybe recently started paying dividends. So I don't think has Apple paid dividends at all?
They haven't in the past.
Well, it says they're going to increase, so they must have just slightly started a little bit ago. I didn't think they were paying any at all.
No, they paid a couple of dividends. Yeah, they just weren't paying a lot.
Huh?
See, they were sitting on $150 billion cash.
Right.
And that was that lawsuit was about, why aren't you giving us some,
Right.
in the form of dividends.
Yes. No, because I didn't think they were really paying much of anything at all. But I don't know. To me, it just seemed like an absolutely horrible thing to do, and they're being pushed around by their investors. And when you get pushed around by your investors, then you become something like Microsoft, or you become like the normal companies. And you need to really analyze the risk. Because Jobs was fired because he was really risky, but then he was rehired because he was really risky. And so the better thing, when Nick and I were looking at it, was just let your stock price fall. Don't worry about that. Just invest, $30-40 billion into that, and buy up all your stock when it's worth almost nothing or almost all of it, and then wait for your stock price to go way back up around 800 and sell it back off, and you'll make way more than you ever invested, whatever it took you to buy it, and you'll be up around 200 billion in what you've made off the deal. So this just seems like an absolutely foolish move, and really, unless they're having a product release in a month, it shows that they're being pushed around by their investors. So that was kind of our analysis. I just want to see before.
Did it say that they actually did that, or it's the company just saying they plan on doing it? Because if they just are saying that they're planning on doing it, it could be just a hunch that they're just kind of throwing a bone out to the investors to kind of boost their confidence, but they may not actually go through with the deal.
Maybe, but they don't really need any investment. They've got $130 billion on hand. So there's no real. Huh?
At that point, though, when you've got that much money, you're not really worried about cash. You're worried about your reputation, and you're worried about where you're going to be able to take that in the future.
Right, and so that's why you spend this in your R&D, lots of it. They're putting the new fusion reactor, the one that's actually supposed to run in France, is costing like $17 billion. So with like $30 billion in R&D investment, $40 billion in R&D investment, or even 60, I mean, you can develop some amazing stuff. And to be in control of your reputation, they really need to reach out and like grab onto it themselves and not worry about what other people are thinking. Which from the MBA kind of standpoint on it, they're much more relations, how can we do this, but from kind of the engineering, the logic standpoint of it, is the only way to control it is to really grab it yourself and force it to happen, so, which is done by R&D.
I mean, like, with this article, it says that it's, like, they're stating that Apple needs to stop, like, you know, what is it, upgrading what they have already now, or I think that's what it said. I mean, I haven't really seen Apple's vision, like, going beyond that than what they have right now. And do you know what their vision is beyond that?
No, no one does, but, and that's kind of, and to really control your stock and to make lots of money off your stock, that's kind of what you need to do with it, so then your stock will fluctuate and then you buy in when it goes low.
Good article in Wall Street Journal, which comes right back to what you just said. See, you wouldn't ask the same question of Samsung, would you? What's your vision? Samsung? Apple has got a reputation as being an innovation company, and they're stuck in that reputation. As a matter of fact, they were saying that if you classify them as a hardware software company, they're doing really well. Their stock should be at the peak, because they're selling a lot of stuff, and they're developing a lot of software. But people are not seeing what they're used to seeing from it, which is this highly innovative stuff coming out. So they're having a little bit of a reputation issue right now. And that's why, you know, your question is, well, what's your vision for the next big thing? You know, they've set themselves up inadvertently at the company that a lot of us expect a lot from. So part of this 40% loss is a lot of psychology. It's not really the health of the company, it's just that, you know, the leader is gone, the new leader hasn't done anything. I mean, what have you done for me in the last 5 minutes kind of thing. You know, so it was a real good article, and they're suffering because of that, and the dust eventually is going to settle. Not to mention that Samsung is really aggressive, right?
Yeah.
You know, Samsung conquered Sony. That was their first goal, and now their goal is Apple. I mean, they're adamant about it. They're going to beat Apple. I don't know if you noticed, in the Wall Street Journal 2 days ago, they had 4 full-page ads. 4, I mean, page after page.
Wow.
So what I'm just looking at is amazing. They're going after Apple. I mean, they're smelling blood, basically, right now. So it's a pretty interesting war.
It's
Although
because of their...
I have a lot of Apple stock, so I'm not happy.
Yeah.
So.
Well, and it's just because of the new leader. I mean, it's there. It's not.
It's just that uncertainty, and also they're stuck in that innovation image. And innovation doesn't happen every day.
Right.
You know, it's.
It does when you have $137 billion. It can.
It can. You're right.
But the new leader there doesn't seem to be willing to take the risk to really make it happen. So, at least from what it's shown so far.
How long has he been on the job now? 2 years. No, did he really come in 2011?
You want to vote next? Or you want me to show you?
I don't know. Remember I told you next week?
Oh, okay. No, alright. Somebody sent me something about
Oh, that was John and I. Yeah.
Oh, you. Alright.
Us.
You guys want to present? No, you want me to show something on the 3 gun? It's up to you.
Well, we can do
Yeah, do the,
Alright.
run the tape.
I looked this up ahead. I think it's oh, houses.
Yeah, I would actually show you one, or unless you got something else.
I got some things. It's innovating, but it's doing it through a starting with a nonprofit and then joining a new company afterwards. You guys watch one back?
e-weapon project initiative to raise $20,000 to design and release a plastic gun that anyone can print from their own computer. It would be distributed for free. It would allow anyone who wanted a gun to get one just by hitting print. I will tell you that I said last week that we are going to come to a place where people are going to print guns. And people on my own staff said, nah, I'm not going to do that. Really? Here they are, all printed by a 3D printer and the magazines. How are you, sir?
I'm doing well. Thank you for having me.
You can't print the whole gun because it's illegal.
That's right. That's right. It's actually legal in two different ways under Title 18 to make undetectable firearms or weapons that would not be regulated by Title 1.
Okay, but you can fire this.
I have fired them.
You have fired.
That's right. Yeah.
Okay.
And I fired all these pieces as well.
And you made all of this yourself, or
This trigger group is a standard trigger group we fit in just to show that our pieces were right, our measurements were right. The white piece is the printed piece.
Now, here's what I mean. This is both exciting and frightening because every dynamic on planet Earth changes. You know, it's frightening because Occupy Wall Street, take over the world. It's wonderful because the Holocaust wouldn't have happened. I mean, it just depends on how you decide to use them, which is meaning that we have to be in control of ourselves. Because if they try to, and they will, they've stopped you from making the gun, right? You're not going to make the whole gun.
I've been disciplined from not making it, but I'm going to make it. You know, it's just a matter of following their law.
Okay. So you'll do it the right way. Is there any doubt in your mind that those who are nefarious, who have the same, you make anything? Why go buy and smuggle your guns through Eric Holder when you can just print them?
Look, if Eric Holder's giving away N16s for free, I'll take it in. But right, this does add some questions and some complexity to things. Undetectable firearms, unknown firearms in commerce, assembled out of parts that aren't registered. There are new dimensions, new folds, new more problems.
Okay. Any way to put the genie back in the bottle?
Now, I'll show you. This magazine, for example, right, was just one file 2 days ago. Now it's been downloaded over 50,000 times. You know, the internet has it. And as long as these machines keep getting better, this is no longer bannable in some traditional sense, in some progressive sense of control.
So in other words, they can ban it all they want, but somebody is just going to print it. And this was all just printed on a 3D print.
That's right, an SLA from the 90s. It's an old technology in each case. You know, I don't
The
have
first time I ever saw this, I was in Jay Leno's garage. And he had a Stanley steamer. And he said, you know what it's like to get a cog for a Stanley steamer? And I said, no. And he said, until this machine, you couldn't get it. And he showed me, it was as big as a huge refrigerator. And he said, just put the broken bits in there and it scans it and then it just makes it. And I thought that was amazing. And I own that one. I mean, and that's like a little, that's just like a little one that is $2,000. These replicators, to make this, how much would the replicator cost?
Oh, a replicator making that?
Yeah.
We haven't made one on a replicator, but the volume under
How do you make this
under $50.
in a 3D printer?
Yeah, we made it in an SLA 3D printer, which uses a little bit different technology.
Which is what?
This was made with a laser and a UV resin.
And that's when they come together when the lasers hit?
Yeah, more or less. There's two different technologies, not to get too complicated, but it cures a resin in the resin polymer very quickly. You're done in about 9 hours.
And how much it cost you?
About $100 in material.
And how much does the actual printer or the machine cost you?
Multiple thousands of dollars, but demand will drive prices down. It's just a matter of time and what technology the market prefers.
What is the thing that, do you have any concerns at all about this technology?
Well, we're doing this project and using this technology as a form of resistance. So it's just a critical use of the technology. Of course, we have concerns at the end of the day, right? But we see liberty under threat. We see sovereignty under threat. We must respond.
So they try to take this, they can't take this away because everything, the technology is out and everything is being mapped And you just really do, it was shocking to me, all you really do is hit print.
That's right.
You download it and you hit print.
This is an alternative way of manufacturing things, and it really takes out almost all expert required knowledge. The model is already in software. You can download it. If you have a machine, you just tell the machine to make it, and you have it. It's that simple.
Okay, so, America, here's your decision point. Your decision point is, is this guy a hero or a villain? What do you think you are?
I don't like the dichotomy. Right? In whose conception, under what paradigm? I'm just resisting. What am I resisting? I don't know. The collectivization of manufacturing, the institutionalization of the human psyche. I'm not sure, but I can tell you one thing: this is a symbol of reversibility that can never eradicate the gun from the earth.
I'm big into whys. I know why I do everything. And that's where we connect, is on why. So I don't think I buy your BS on what you just said to me on why. Oh, I'm this or I'm that, I don't know. Yes, you do. Why do you do it?
I do it because I decided the process isn't the way to preserve liberty. I don't believe in
What does that mean?
I don't believe in Romney versus Obama. I believe in real politics. That's a real political act, giving you a magazine, telling you that will never be taken away. That wasn't true maybe 2 weeks ago. Now it's a fact of life. It's a fact of history. That's real politics. That's radical equality. That's what I believe in.
Are you concerned at all? See, these are the debates we're going to have here. Are you concerned at all about things like, and the gun is somewhat different because this is the great equalizer, if you will. Whoever had the gun manufacturers, whoever controls the gun manufacturers would win until this. Okay. However, just like the music industry and the movie industry, if you can copy things, then somebody who designed it, somebody who spent money and time and effort to design it, you're taking it from them. What happens to the patent? Does that?
I designed that. And that was my property and I gave it away. If we accept that conception of things. So, you're welcome. But
wait. You didn't, because you didn't, somebody else designed.
The magazine is our design.
It's your design.
It's distributor's design.
Okay.
Our proprietary design. This was an old, the AR lower design has been out in the wild for years. It's a mil-spec kind of design. It's not any one person's, although Eugene Stunner is
Okay, so would you agree that patents are important or not?
Oh, okay, down the road. Yeah, intellectual property is an interesting debate, and I fall on both sides of it. So I see an interest in preserving a legal monopoly sometimes.
It's what made America America.
It makes some sense, and at the same time, I'm partial to the debate of kind of the anarchist left, which is that really these state monopolies allow undue profits.
Okay, so are you an anarchist?
I guess in a functional sense, sure, but perhaps like a principled one.
I don't know what that means.
Well, there's a guy named Michel Foucault, and I recommend that you read him sometime. Really, I see the battle as one of just trying to remain human, and against massive forces, anonymous forces of discipline and control that we can't really understand. I don't think there's a massive conspiracy, but I do think the self is under siege, and I think liberty itself is under siege. Human spontaneity, the freedom to do things.
I would agree with you, but if it devolves into either chaos or totalitarianism, you've lost it all.
I think there are different visions of what totalitarianism is. It seems to me the progressives and the conservatives are both lined up against a strong state authoritarianism either way. Either it's a socialized collective vision or a more kind of police. Well, either way.
Yeah.
Both seem to me to be the authors of an increasing surveillance and police state. I don't agree with that.
Have you read much about the Articles of Confederation and okay?
Yeah, definitely.
I mean, there is a point in liberty that even the most libertarian or close to anarchist member of our founders understood you have to have some
state power.
You have to have some power just to hold things together, as limited as possible.
I like the argument, and I'm partial to it, and I like the founder. But I think I never want to say this time it's different. That's a kind of progressive argument, you know. But Cody,
You are, I don't know if we are friend or foe.
yeah.
I appreciate the debate, and I appreciate the idea that man will be free. Man will be free. Because this is not going to stop. They could put you in jail and it wouldn't matter. This isn't going to stop. So, thank you. Back in a minute.
You should find out for
I wonder how he prints out the metal
He's
puppies.
looking at, while it is a
You can just switch it.
organization now, non-profit, it's really sort of an arms manufacturing company. So, this is how we start. You guys can present now if you want.
You know if that's all plastic or?
That one is all plastic, and kind of the law falls under it's undetectable, but you can print it in metal. It doesn't. You could print it in medical grade metal if you wanted. There's enough for it. It's kind of an interesting way to go about starting a business. He's a law student too, by the way. Out of Texas. So what do you guys think about 3D printing guns? Yeah.
You're gonna be more specific than that.
No, this is an open-ended question. You have to drag it. You have to drag it over. You gotta. No, you gotta drag that over. I don't know how much. No. You need to close that thing, drag it on the other screen. Is it?
It's set up as a Zoom monitor.
Yeah, it's not a mirror. Yeah.
We all set?
Yeah.
Okay, sounds good. My name is Alex Balo. I'm a senior 2 student here in the ME department, and this term I got an exciting opportunity to work with Professor Vaishnava in the physics department on a research project on graphene synthesis, along with John Casey.
Yeah, I'm John Casey, also taking this class in nanotechnology where we discovered the process to develop graphene.
The concept was initially suggested by Professor Vaishnava that we look into various types of graphene synthesis for our final project in the class. So we kind of went above and beyond and got some lab space set up over in the chemistry department, and we're actually using one of the methods that was suggested out of like a list of 7 or 8 different methods of graphene isolation, because we saw its merits of being a low-cost, sort of a green alternative to graphene production, which is fairly energy intensive right now, and it's still a very high-cost material. So we want to start a research-based company founded on designing sustainable methods for graphene production. And our real main focus is bringing it to an industrial scale that can really drive the price down to make graphene, which is a real super material. We'll get into some of the properties, but we want to get it below the price of steel because it has incredible recyclability and incredible mechanical and electrical properties that can be utilized in anything from structural members all the way to thin film screens.
And also, we have full backing from both the chemistry department and the physics department on this project.
So yeah, we got lab space in the chemistry department, but it's right now being backed by the physics department. So what makes us different from other graphene manufacturers that we use completely all organic compounds that can be found in off-the-shelf materials at your superstore.
It's a low energy process. Everything is done at room temperature.
Yeah, everything is done at around like 20 degrees Celsius. You don't want to boil anything or heat anything up, unlike traditional processes which use like carbon or like methane furnaces that leave graphene films on semiconductors. That's a very energy intensive process. And our goal is, once we do some of our initial testing with some various organic compounds that contain antioxidants, we want to check the sample purity, which we can do with an array of different testing devices we have here on campus. We've got electron microscopes, X-ray diffraction machines that we can use to check the Raman shift, and all sorts of other like UV detection to determine the purity, because we want a pure carbon crystal lattice of repeating hexagon shapes. And right now no one is developing organic antioxidant reduction of graphene oxide on an industrial scale, so we could really get a heads up on the market.
So
but what is graphene?
Graphene is basically just a single atom layer sheet of carbon molecules arranged in a hexagonal pattern. The structure is very strong, 200 times stronger than steel, just alone. It's very conductive, can be used for things like supercapacitors, it's also a semiconductor. Very thick, almost nearly transparent, which gives it the ability to be used as screens or windows.
Yeah, incredibly thin and flexible once it's in a sheet form. So you could like turn your iPad or tablet device into like basically a little piece of like cling wrap that you just roll up, you can slide it in your pocket and then roll it out and use it as like a touch screen. You could use it for TV screens, and even though it has a zero band gap, which basically makes it nearly a superconductor, with the right manufacturing technique, it can be grown on a silicon carbide surface that is ridged, and you can actually tune the band gap to whatever you want to make it a very viable semiconductor that would replace all of our electronics, allowing for faster frequency switching in transistors, faster processing. It's 200 times faster than silicon in its electron transfer, because the crystal structure is so tight, and it's two-dimensional, so the electrons are shooting right across and they're not going through a three-dimensional plane. So it really has a lot of unique properties that make it actually the strongest material currently known to man. And in 2004 they started a lot of research on graphene, and actually just a few years ago in 2010 two Russian physicists synthesized some samples of graphene just using Scotch tape and pencil lead, and they just sort of kept on dividing the sheets of pencil lead until they came to 1 atom thick, and this sort of clicked the light bulb in saying that it could be a large-scale manufacturable product. When up to that point, it's been known about for maybe half a century, but it is very expensive to synthesize, and this sort of opened the door to allowing this awesome new material to be involved with our daily lives.
Yeah. So the applications for this material are practically endless. We can have the ability to make supercapacitors for all of our electronic devices, which would allow us to have phones that would charge in just 30 seconds and have power for hours. Cars even, mobile technology, just removing the heavy weight of the battery and replacing it with lightweight, extremely lightweight and powerful capacitors.
Yeah, there are a lot of businesses right now that are trying to scramble in the market, but they're utilizing sort of tried and true technologies. So our advantage would be in having a research and manufacturing division working sort of simultaneously, so we can continue like R&D in taking our graphene powder and turning it into structural materials and different manufacturing techniques. And yeah, you can use it for a lot of things, and you'll probably see graphene integrated into electronics within probably the next 5 years or less on a commercial scale. So raw materials are very inexpensive. You can source graphite, which would be our main source of pure carbon, for around $500 a ton and up. And our plant material that we'd be synthesizing our organic acids from can cost anywhere to $3.50 a kilogram. But graphene itself, when isolated in very pure form, can range anywhere from $40 to $800 a gram. So it's a very kind of hot ticket item. You can see why companies are investing a lot of money into getting started up in this business. And since all the reactions happen at room temperature, our energy input is very minimal. Our grinding methods are going to require very low power application. And I have a background of about like 4 years or so in advanced manufacturing techniques, working at MTD Products as a special machines designer, so I can throw together all sorts of cool contraptions to build and manufacture whatever on a pretty large scale. One of the assembly lines that I worked on produces over like 6 million units annually of lawnmowers. It's like a full automated line. So if we did get the support of KES, first off, we'd make an investment in our own lab equipment. We'd buy a ball mill that can get particle grain size down to nanometer scale, and or micrometer scale. We get a nice optical or microscope that we can hook cameras up to measure our grain size. We need all sorts of beakers and glassware, and a nice balance that goes down to the thousandth of a gram to make sure all of our reactions are balanced and to have accurate research starting out. And we'd also need a few raw materials. Luckily everything is inexpensive, so $600 will go quite a long way in getting various types of graphite, graphene oxide, and other components that we can test and experiment with. And we'd also need a little startup money for a website and some incorporation fees. When all that is said and done, we've got $53 left to set aside just in case of emergency.
Pizza.
Exactly. We'll need some food. And thank you. So are there any questions or comments?
How do you break it down? What's your process?
Well, that's what we're researching right now. We've got a couple different processes that we're trying at various grinders to get a really good particle size. We're starting out with different types of tea that are known to have high antioxidant content. We're basically going to use the antioxidants to cling onto the oxygen molecules, which sort of puff up graphite to graphene oxide. We'll sort of pull the carpet from under the graphene flakes, and through this process we can run solvents through to wash out all the byproduct, and then check our purity. So it's a fairly simple process, but no one right now is doing it on a industrial scale.
So what does graphite have in it that the stuff, the cheap product you're trying to buy? What additives does that have in it that needs to be removed for the graphene?
Graphite's actually mostly carbon.
Yeah, graphite is pure carbon, so it'd be
Just a
perfect
different
in
structure.
where it is.
What's the structure?
It's graphite is basically in its crystal structure is just a bunch of graphene flakes that are just stacked very tightly together, and that's how they could pull them apart with Scotch tape. But there are van der Waals forces in between layers that hold it together. That's why you need to oxidize the graphene first, or graphite first, and then that separates the van der Waals forces, and then while it's in solution you can pull away those oxygen molecules with antioxidants to make it happen. So when we're done, we're hoping to come up with a fairly high carbon content graphene powder that can be used for industrial, maybe structural applications, because for the electronics, the graphene costs quite a bit more because it needs to be perfectly pure crystal structure, grown in sheets, especially for semiconductors. So we may stray from that for a while, and we'll focus on bulk graphene powder of various grades.
Is there an easy way to get powder into sheet form?
You can use a bunch of different methods, like vapor deposition, or you can use like lasers to like etch out different shapes, and you can use you can roll the graphene into a nanotube form, then you can unzip them and then lay them out and make graphene ribbons. There's a whole bunch of stuff that we'd be experimenting with.
Before going into like details about a really good presentation, but I saw your financials and like the request for like KES. So actually what we have done, like we have changed some of the structure. First 6 weeks is just concept introduction.
Oh, okay.
So like there
We're
is
coming
like
back,
a
don't worry.
KES
We're not
grand
going yet.
philosophy and guidelines.
Okay.
So like just to reiterate to each and everyone in the room, the first 6 weeks we just have a concept introduction where you don't talk about any financial things, because if you show the financial things, people may get biased about like why you're buying this and why you're buying that. And like
We can take suggestions.
yeah, so like there are suggestions if you have a right business path or not, or you should like pivot, or like, and if you're ready with the business idea, then you have to come for a grand presentation where you just give the line items. You don't talk about the financials at all.
Okay.
So, and then in the 8th week, you come with the financial details when the line items are approved. So this is the procedure we follow. And also like the team has to be recognized as an active KES member involved at least one term. That is, means we have some requirements, and there are like funding restrictions. Now your like idea can fall into a tinkering fund, or maybe it is a business idea. So like there is a evaluation sheet over here which can help you, and also like the limits are different for both. Like tinkering is around $1,000 and this is $3,000. Means I didn't want it to like just, it came through my mind, and just wanted to reiterate, and we can go ahead with the questions.
Actually, we have a lot of new members, so it's worth pausing on that a little bit. So if I may reiterate what Sagar is saying, the value of the first 5-6 weeks is to help this team refine their idea, both from a technical point of view, if we can help you. I mean, this certainly is a deeply technical issue, and also with an eye on the line of business that they're trying to pursue. Like, what are you really doing here? Are you proving a concept? Are you looking to establish a business around the product on this research? So we're here to help each other. I mean, you're part of the group now, to help each other understand and refine it. So we're gonna, so you can come back next week and present again, you know, say, oh, okay, I heard you say. So that's what this conversation should be all about. And I have lots of questions along those directions. I wanna understand better where you're going with this, right? Then, eventually, we get to a point that we have to make a decision as to what stage of development are you in. Are you ready to roll out a business, or are you still in the lab proving a concept?
Yeah,
I
most
try
of the
to help
materials
you-
are for lab.
Yeah, try to help you along those. Now, in the past, we've called being in the lab proving a concept tinkering. Kind of like, you know, some of our members come up and say, hey, I just want to prove something. I don't know what I'm going to do with it, but I want to prove something. Give me some funding to go do that. Okay, so it may fall under that. We've put some loose limits on these things, so don't be too focused on it. There's always room for you to persuasively convince the membership that you should be exempted. You know, we always leave that door open. So, because after all, we're here to learn how to be persuasive, right? That's part of our entrepreneurial mindset. So we're always leaving that door open. But what Sagar was trying to explain is that, you know, financials get in the way. People start focusing on, well, shouldn't you buy 2 of this and 3 of that and 4 of this, you know, $50 saved here, and, you know. So don't worry about that. That comes as your last presentation, right? And even before the last presentation, you're gonna come in and say, okay, now that you all understand our idea, you've helped us refine it, these are the items we really need to accomplish our goal. And then we go through another round of discussions. Do you really? Right? So that's why how the network helps each other. It's a bunch of brains in the room instead of 2 or 3, right? So that's why we're doing this, and I hope it makes sense for us to do that. So tonight's discussion hopefully is just trying to understand what you're trying to do and help you. So, right? Is that fair enough? Now, that other requirement in there that you should be an active member for at least a term. Now, I know that you've been here before, Alex, so we're gonna have to discuss that. The reason we put that in is because people would show up in the middle of the term, make a presentation, expect money. So we're trying to slow that down because the value for this society is this discussion. The value is not for somebody to show up and get money. That's not what this society is about. That's gravy, that's just gravy. That's frosting on the cake. The value is for this discussion to happen. So we can understand from your brains, and this is good stuff, so I want to know more. What are you doing about this? So hopefully we'll deal with that as we go. So there's some room for that. This is definitely not a red flag yet. Okay, so I wouldn't be worried about it. So having said that, let's get back into the discussion. Let's start understanding what you want to do with this thing. I guess the one question I have, I missed the very beginning because I was talking to Hillary, is are you guys working on this with Professor Vishnamar right now, or is this your own brainchild now, or? how's
We're
that
getting
piece?
like pointers from him.
Or is it your mentor?
It's yeah, he's it's actually for just a regular like 300 level physics class,
Okay.
where at the end we're supposed to have a deliverable, and like just a presentation that talked about nanotechnology, but we asked him if there was anything we could do hands-on in the laboratory, and he mentioned a few different things and said that he had a friend in at Wayne State that is like a top graphene researcher in like the Midwest area that he works with, and because we came to him with the idea that we wanted our final project to be involved with graphene, and we wanted to see if there was anything hands-on we could do with it, and he said, actually, yeah, you could synthesize it if you want. There's a few untested methods that you guys could actually get your hands on, some of the scanning microscopes and some of the equipment, and we'll help, or we'll provide you with some like money for materials and stuff if you guys want to do this for like a class project, basically. And he also suggested that it'd be a very, very interesting business opportunity for us to start if we were ever interested. So
That's how you guys started.
Yeah, so we started looking into it and really diving into a lot of research papers about graphene and various methods that have really only been recently developed in the past couple years. There's been a huge boom in various production methods, but there's really nothing out there on using organic like antioxidants for graphene oxide reduction, which is would be the most inexpensive process available right now, and would really be able to scale up production pretty large, pretty significantly.
Something you guys came up with, or is that in that?
Well, the idea that we would use an antioxidant to reduce graphene oxide was sort of a concept that was sort of on the table but not researched yet. That was suggested.
Start thinking like that.
Yeah, that's sort of what our research is using several different processing methods that we're going to compare to see what kind of particulate size we get out of grinding certain items for certain amounts of time, so we can really kind of hone down some base data that we can use to scale up to make a large sort of all-in-one machine. You just hit a button and it cranks out kilograms a day.
Oh, so like, I just sort of curious on the process. So you can like patent the process that you should produce something, and then so there's like two patents. Like you can patent the way you make it, and then the patent you can, and then you can patent the product. Okay.
Because we can vary the different solvents, we can vary a lot of chemical reactions to hone it into our own sort of patentable process.
Right.
Once we discover what works best, we'd go with that.
They could also get a patent and just like sell it to some huge company too. Right?
Yeah, there are a lot of...
like you just like make a quick buck on that.
That's a business model issue. Yeah, that's that after you come up with a patentable either process or product, how do you commercialize it? That's one way to do it.
Yeah.
Luckily, there are a lot of graphene or graphite oxide suppliers in the area that we saw some research papers where they did testing in like South Korea, and they specifically ordered graphene oxide platelets from Bay Carbon up in Bay City, just like down the road. And there's also another company in Lansing that we could possibly work with that is using like more high energy intensive processes of graphene production, and their prices are pretty high. So this could be something that we could sell to them or combine, or use it as a stepping stone for other business ideas that we have.
So it's fair to say the product you're working on right now is the process of creating graphene in the cheapest, most easiest way
Yeah.
that nobody else has tried.
We're zeroing in on like the
Possible.
basically pencil lead, fuel line cleaner, and tea bags.
Okay, that's fair enough. So that's what you're after.
Yeah.
Now, what people do with it after that, you're not thinking about.
With like the powders,
Right, yeah, what products would you make
probably mostly like structural materials.
But that's not your concern, right?
No, we want to just bring massive amounts of it to the market to lower the price, so we can get it competitive with other materials, because it has such incredible properties that can really enhance people's lifestyles and bring electric vehicles to the market very easily and increase efficiencies of all electronics. It'd be sort of like an Andrew Carnegie sort of move with like getting steel out there.
I was just going to ask you that. What's the analogy to this? Right? I mean,
This material is
a exotic material. You can just pump the market with a material that nobody knows what to do with it, or it doesn't have the properties they want, whatever it is. It's just producing some fancy.
Yeah, luckily it has like superior properties in heat conductivity, electrical conductivity, and semiconductor frequency, and it's the strongest material ever.
I'm sure later down the line there will be ideas for application for the graphene.
Yeah,
I would think.
basically giving the toddler some Play-Doh.
I've got like a list of 4 or 5 things that I've got questions / comments on. I guess to start real quick, intellectual property. If you guys have a way to make it that's not patented, it's worth your time on something like that, definitely, especially if it comes out to where it works and goes where you want it to go. Having that is going to be huge. And you can't be too quick on that one. So if you come up with something that works, and instant.
It's all first to file
It's-
now.
Yeah, be
So-
very, very, very quick on that one. Same with any equipment that you come up with. If it proves that it looks like it's really gonna work, jump on it. Don't let anybody see it.
Yeah, green flag. Need this much graphene in there.
Yeah.
This didn't
No, a meeting like this doesn't
Sorry,
void.
Kevin, just interject. We have a standing agreement amongst members of the society. We're all under non-disclosure.
That's where I was.
We used to sign papers, but we now verbally tell each other. Now, non-disclosure means what you read in this room is not public disclosure, which gives you the protection for potentially patenting it. I don't know if you guys know or not, if you go out there and disclose your idea, then you can't patent it anymore because the cat's out of the bag, right? That's called public disclosure. If you talk to people under NDA, you've covered 2 things. First of all, it's no longer considered public disclosure, so this is private. Second of all, those people supposedly have agreed not to, do something with your idea. Now, at this stage, you don't need to worry, because you can tell me until tomorrow morning that graphene is great. I'm not gonna get up and go, oh yeah, let me go make some. That's still your baby. But when you get close to actually discovering how to make this stuff the way you think you're gonna make it, you wanna make sure that you really have some NDAs and stop talking to people unless you have to, that type of thing. Okay, and start really thinking about what Kevin is saying, which is start looking at patentability, make sure you know who are principal inventors here. So
Yeah, that should be
keep that in the back of your mind.
key and not quite as important as working on it, but pretty close up there. Where else was I going? The graphite powder that you get, what is that used for? Just out of curiosity. Obviously, you're going to be using it to derive your graphene, and synthesize it, so on and so forth. What do they use that for now? Not that that really makes a difference, but
With the graphene oxide,
yeah.
The graphene oxide or just the graphene?
Or not the graphene, the powder that you
The stuff we'd be
the stuff
producing.
not the stuff you're going to be producing, the stuff you're going to be buying. to
Stuff
produce
we're
what
buying.
you're gonna produce.
well, we can buy just regular graphite or even coal, and synthesize
So it's
the
just a
carbon.
refining process.
Yeah, we just need carbon basically.
It's how far you refine it.
Yeah,
So
any form of carbon. It's eventually want to get it to graphene oxide, which is like graphite to. It's basically just ground up pencil lead that's oxidized, and then. But we can use a variety of different feedstocks, like garbage, just like funnel it in, burn it, and then collect all the carbon. So it's a zero emission process because we're using all the byproducts of the reaction, and we could buy CO2 from people and synthesize the carbon from that if we want.
Product's cheap.
Dirt cheap.
Yeah. And luckily, all the coal supply in the U.S. is some like the highest grade, almost like 97% carbon content. So we're lucky to be in the U.S.
Is that like in relation to nanocarbons? Like, is that something totally different?
You mean like carbon nanotubes?
Yeah.
Yeah, if you like roll graphene into like a little tube, it's a carbon nanotube.
Okay.
So with this base powder that we're hoping to develop, you can turn that sort of like basic sort of building material into all sorts of different things, carbon nanotubes or whatever, and then you can spin threads into super suits, whatever. You can do all sorts of stuff with it.
So I got a logistic question. So right now, we did a lab space right now?
We have a lab space set up in Bell Lab 2, and there's no classes in there this term, so we're working with Professor Wang over there. And yeah, 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 we have all free access to the equipment in the physics and chemistry departments right now. And if we need to build anything, I also have access to all the ME like machining centers and that we have in the basement of the AB, because I'm working on my capstone project, which gives me access to all those also.
So what do you need right now to start thinking?
Well, if we had
I'm getting a little ahead of myself.
yeah, well, we figured that right now, since we're in such a like beginning stage, we need to complete our initial tests through our class, because we have a deliverable of producing some sort of result by the end of the term for our class. So we're under the clock for that. But after that, we're sort of open to expanding research on our own time, so we don't have to wait for a professor to unlock the laboratory for us. So that's why I wanted to get our own little clean lab set up that we can go in and spend hours upon hours of research time on our own clock without having to bother any professors or anything.
So it's not immediate, so if the end of term
Yeah.
is cool.
Yeah, that's what we want to go.
So maybe next time we talk, we should talk a little bit more about that. What do you mean by clean lab? Because I'd hate for you to have to repeat equipment that's already here available for you to do.
This is
Even
what
after
after
your
we-
class is over, we can get you access to people's equipment and labs. The only downside there is this. This university has a strange policy that they apply to faculty and they haven't thought about applying it to students yet. And I'm trying to get them to, maybe you might push that point for us. If we innovate something on campus here with, the clause goes like this: significant use of the Kettering equipment, that's the clause. Then Kettering is entitled to partial ownership.
This is a
Print that out.
professor's,
That's the professor's deal.
but if students,
Yeah, print that out.
I don't know that.
okay.
They have never written a policy as to how does this apply to their students, and I've asked them that question before. And they've said, well, we'll think about it.
Because Wayne State, that's what Wayne State does. Like, if you develop something at Wayne State, they get like 20. I think it's like at least 20% of it.
There's usually numbers and
something.
things.
Yeah,
We
like-
have that too, but it says for the club. It has not specifically said what happens to the, I mean, they say employee of campus.
Yeah, like
It hasn't specifically said what happens when students.
I think we try to stay away from that because we co-op so much. And
Well, this is what I prefer. I would prefer for them to leave you guys alone, give you full access to everything. That's what I'm pushing for. So, don't go after squeezing from one to the other. Yeah. What I'm hoping to do is that. However, I just want to make sure that you keep that in mind and start asking questions. The upside is you get access to the labs. Why would you want to go buy all this expensive equipment?
because you're a senior.
If you can
Yeah.
just pull it out and do it. The downside is if they hold you to that same clause, at some point you're gonna have to divorce yourself from the university, when it
Yeah, that's what I was
starts
unsure
getting real
of.
promising, you gotta go on your own.
How much of their materials do I use, and how much are they entitled for that material use?
Well, that's
if
the
it
thing.
did-
Right now, the clause is ambiguous, it says significant use, right? Now, I'm sure if you start using all the microscopes and the sophisticated electron scanning devices and all that, they'll start seeing that as a specialized significant use, right? And it's legitimate.
If we could
You're
apply
really using
things
it
like that to just the project though, and say that we were only using the
For your
electron
class
microscope.
project, you're okay.
Exactly.
But I'm talking about an half-class project, when you really get serious about doing something do it tinkering, right?
Right.
See, right now you'll do something, you submit a report, I'm not sure how far you're gonna get by the end of the day. Whether you put the concept is maybe. But after that, I'm sure you got another 3 to 6 months of doing stuff somewhere on campus, hopefully, right? We can try to even find room for you to do it. And that's why this society tries to do, try to facilitate this. I can go knock on a few props door and say, can you get access to that, to these guys? Because they're really serious, they're doing good stuff. The only piece that I gotta settle with our provost is, can you take their hands off of what they do? If they come up with something. So right now, I can't promise you that because it's ambiguous. So I'm just putting it out.
Okay.
I'm not discouraging you. I still think you should use it out as much as you can.
Somewhere that might be a line that separates as well. I think this is the first time I've ever seen a use for any of that. What do they do? One, what do they do with the innovation centered on the street?
Yeah, the innovation-
Because that has all of the lab equipment that you need, and that is rental space.
Yeah, at some point you guys may have to become clients and start renting that. Then you're not under that clause anymore.
Yeah, that's kind of what I was
You're
saying.
paying.
Where could you get that? It's rental space for no money kind of deal.
Well, it's more the equipment. I'm more concerned about all the electrons, scopes, and whatever you guys need, and the SDMs and all of that.
Yeah. The lab tech of the physics department said that as long as we're students, the catering doesn't charge or even
Right, they don't charge, but if, this has never happened at catering. The problem is, when an IP shows up and you start patenting something, that's when everybody says, wait a minute, where did you develop this? In our labs? And that's when it shows up. So we gotta make sure, it's too early, this is a premature conversation. We're gonna have to wait until you guys start sniffing something.
okay.
Okay?
Did anything come up with Justin when he was working on his?
But he hasn't.
Because he was like using. Well, yeah, I guess they
No,
have.
he didn't use heavy use, I mean, he used the computer and some little code and a few things here and there. But
He didn't use
hasn't.
it. I thought he used to crash safety whenever the.
We did not use any equipment.
No, he didn't use it, he just used it to test it out.
Oh, okay.
Yeah, we're just playing around. But besides that, he hasn't done anything with it. He hasn't created an IP, he hasn't generated a dollar yet. All these things are moot until you sit on something that's of value.
Okay.
That's when everybody and their brother shows up.
Yeah.
Before then, who cares? Yeah, great. Shmuel Tinker.
Will they know about that? Like, when they file IP suppose for this?
How long can you hide an IP, especially if it's tagged with a product?
And like there is no written rule for like students, so like.
That's what I need to figure out. I want to know if the students are in that policy or not.
Is there
So is it better to like keep quiet and
keep quiet and take advantage of the benefit of that. You can't keep it quiet. Never think that the world's not going to notice that you're going to do something. Never happen.
Is this written somewhere?
Yeah. We have what's called the IP policy.
If you got a copy of the IP policy to them,
I bet you it's online.
okay. If you got a hold of a copy of the IP policy that did not include students, you probably have enough backing in there to,
As a matter of fact,
regardless of where you go,
make it
if
your
somebody
homework.
tried
Go
to get
online
it,
and find the IP policy.
No problem.
Yes.
The intellectual property policy.
yes. Print
Okay.
it, keep it, mail it to
And read it.
yourself, put a date on it, so on and so forth. You started here, this, that, and the other. That way, if
Actually,
somebody
can
ever
you
tried
let us
to,
know
you
next
have a
week?
way around.
Yeah, for sure.
That'd be good, to keep this conversation going.
Okay.
Yeah, this is good. Sorry, I kind of hogged it up. You guys need to ask me questions and help me out.
Very quick question. Where would this stand in terms of strength if you compare it directly to carbon fiber or carbon titanium?
Well, carbon fiber is significantly heavier compared to this for its weight. Like carbon fiber are just sort of giant chunks of carbon with a plastic resin embedded in it. But this would sort of eliminate that plastic resin and be even more flexible and stronger and lighter. It's only about I think 2 grams per square centimeter or so, and it would definitely be a perfect replacement for carbon fiber.
Yeah, exactly. If it's flexible, you can't use it in cars. Can that be rigid also? Like
Well,
a
it's very flexible in like its thin sheet form, but you
add
can
more sheets and
you can add more sheets and you can add structural curves, and it can be as stiff as you want.
Yeah, you can actually link them. And like years ago, when it was being managed with graphene, you got it from 3D structure that was really solid. So no, you can use to replace almost every material we have today. It's excellent. It's great stuff.
Just no one knows how to make lots of it. Yeah.
Who's actually making anything with it right now?
It's mostly just used in like testing. Yeah.
Those ideas aren't the ones used for use of it, but there's not enough of it to actually put any good ideas
Yeah.
to practice.
At like $800 a gram, it's hard to make like a car frame out of it or anything really neat. They've made tried some like vapor deposition methods to make little capacitors and stuff like that, like small scale electronics where it requires very like nanograms of graphene, but yeah, you're not going to see it in like a tennis racket anytime this year.
not bad attitude.
How much do you guys think it'll cost you to make a gram of this stuff?
What's this?
Probably in the fractions of pennies. Since raw materials
Yeah, no,
are
I
pretty.
know where your raw material stuff comes in. Is it a 1-to-1 ratio of your plant? Obviously, you guys need to figure that out.
Yeah, that's what we're doing. We're doing the chemistry
Yeah.
behind everything and balancing all the equations. We know that this needs to react with this, and this will happen. It's just measuring out and finding really good ratios for the different types of feedstock material that we use for our antioxidants.
Do you guys think it'll be, $1,000, $2,000 a ton to get this stuff through?
Of what?
$1,000, $2,000 a ton to make this stuff in terms of raw material input?
Yeah, I'd say that's
$500 a ton. I don't know how much of the other
yeah
accidents.
under 2,000 a ton for raw materials probably.
So the gap that I have in my mind, and I don't know how much of an expert you are in that, but currently it's $800 a gram. That means it's really hard to make this stuff.
You said 40 to 800.
Yeah, depending on the grade and purity. Depending on the purity, it's pretty small.
Right. So is it that it's very energy intensive to?
Yeah.
Where's the problem?
Yeah, right now they use very highly toxic, highly flammable chemicals and very environmentally destructive compounds to drive these oxygen atoms out to form the graphene right now, and they have to use these giant furnaces, and it uses a lot of very dangerous high energy production methods. So ours would be completely 180, completely a green process using organic compounds that you can find at your grocery store pretty much, and all room temperature reactions. So it's going to be quite a big shift as far as energy required per gram.
Yeah, it's just surprising that one method would take so much energy and the other method.
It's almost it's so simple that it's that's the way it should be. So
It's fine, I always get suspicious when something so simple goes up.
yeah.
Somebody else is doing that. But you know what? You never know. Maybe they just didn't look at it.
Yeah.
Same thing, it seems too simple, so it can't work.
No, it's not that they can't work. It's
We'll
just
try it
that
out, I guess.
Wouldn't have somebody else, this is my stupid thing. This is my lack of entrepreneurial thinking. Let me tell you, entrepreneurs never doubt stuff, they just go. Just go.
Sort of what we're
Research
doing.
scientists are always saying, if it's this simple, shouldn't have somebody else thought of it?
Yeah, we've
No,
looked
that's
around
what
quite a
stumps
bit.
me.
I think I've got like 200 pages of like research papers that I've sifted through, and there's like no mention of it.
Okay.
There's been like hintings at it, like you can. These are a few methods, but no one's tried this yet. So we'll see. Yeah.
$800 a gram, like people will buy like this instead of gold.
Yeah, that's about right. It's more expensive than gold, but that's good.
It's 18 bucks and 160.
An ounce, yeah, it's about 16 dollars an ounce. What's an ounce per gram?
28 grams.
They're competing against gold.
That's pretty good.
Yeah.
So which grade are you guys where is it in that price range?
We'd probably be shooting for under 100 a gram range for grade purity. Would be like ideal. But
How is it graded? Are there like standards for grading?
yeah, there are different like platelet size clumps, and like you can get ones that are like 3 layers thick and clumped this diameter, and we got to figure out exactly what we produce with our process so we can grade it and have it like approved by like a third-party laboratory that this is the sort of grade that they're producing. So then we can work on the cost that way. But it's even at $40 a gram, it still be cost-effective for us to do this process. And we're hoping to drive the price down below that.
To what?
I think the goal is like in like way down the road, like $4 a kilogram. Like when it's on huge industrial scale.
So you're saying that it's like best conductor material, so it's
like more conductive than silver.
Was it more conductive than gold?
I think that
Because gold's the best conductor
Yeah.
right now.
it's like in between gold and silver.
But cheaper than gold, if made right.
We're trying to get the price down to like below steel, pretty much.
Why? If there's a market for it at $40 to $800 a gram.
I mean, we're like 10, 20 years down the road. We want to be an industry leader in controlling the price because our process is so inexpensive. But we'll play to market price as it goes and make sure that we don't introduce just like ridiculously cheap stuff that people don't know what to do with, because that would put all other businesses out, eliminate all our competition.
Something to say about that too.
So you're planning to work on this during the work time for next year?
Yeah, I actually am done with my work requirement for graduation. My thesis done with my work, and so I could possibly take a term off to stay here to further do research and sort of work for myself with the project.
I still have one more thesis term left, but I'll obviously be doing what I can. And then we're doing lots of research this term.
Yeah, yeah, you're just in Detroit area.
Yeah, so I'm not too far.
So yeah, I can devote whatever time needed as it goes along. Oh yeah, for sure. So we'll get back with everyone on the IP policy of the school, and then keep everyone updated. I think it should be a neat project.
So I'm sure we'll see you again, probably 6, 7 feet. So keep focus on what is it you really going to ask the society to help you with. So you got some ideas tonight. What is it you really need? So hopefully you can come to that.
Yeah, we'll
discussions will come in.
Yeah, we'll have a clear answer once we further our research a little bit more.
That's good.
But
I think it's exciting.
yeah, for sure. Be a neat thing to get Kettering's name out there for being like a nanotechnology school as well as engineering and all that. Alright, well, thank you.
Alright, let's wrap.